a digital transmitter sends groups of 8 bits over a communication channel sequentially, the probability of a single bit error in the channel is p, so that's probability. Now, I already have this written out a little bit because I wasn't recording the first time. Usually I'll go through and write everything out and explain it, but we'll just be explaining it here. So in part A, it says how many different ways can 2 errors occur in 8 bits? We will call each of these a 2-bit error. Well, for something like this, where we have how many different ways can this happen, we're going to use combinations, very similar to permutation, but the combination is for something that's like this, right? Where the order of selecting elements, it makes no difference, right? But it's going to just, it makes no difference how we select these, right? Because we always have 2 errors in here through this 8 bits. So this is the general formula for it down here, the general equation. You can find more about these general equations in the free notes in the description below the like button. We have 8 choose 2, and then we're just filling this out. So we have our n factorial, which is 8 up here, 2 factorial, and 8 minus 2 factorial. And this is going to give us 28 ways. We're essentially going to have 8 factorial divided by 2 factorial times 6 factorial. Then you're just going to be left with a 7 times 8 on top, 56, divided by 2, gives you 28. So that's like a simple overview of factorial. Part B is where we assume that a particular 2-bit error has occurred. So we assume we know exactly where it is. X indicates an error bit, and this Greek letter that I don't know exactly what it is the correct bit, which is 0 or 1. Whereas what is the probability of this particular event? Well, for something like this, because of, I've highlighted this 0 or 1, and because we know that it only takes 2 discrete values, we're going to be using the Bernoulli random theorem. And the general equation I wrote on top this time, it looks something like this. And so we're just going to plug in everything right here, and then we're going to be left with this as our result. P squared, and then we have our 1 minus p to the 6th. Now, that's going to be the answer for part B. You can notice that there's no 28s included in this part of the answer. And that's just because we're looking at the specific probability. So we're only looking at specific probability here. In part C though, when it says to determine the probability of 2-bit errors in the system, well, we have probability here, and we have the different ways the 2 bits, or the error in the 8 bits, or 2-bit error can occur. So we're just going to really combine these. The probability of 2-bit error is equal to our 28 ways combination combined with our Bernoulli random variable right here, and it's going to give us this entire part for C. And that's how we look at this problem and go about solving for it.